I hope this time is convenient for you. Is it? Okay, great. So hopefully we'll be continuing up to the 27, right? This class fixed on Saturday evenings like this. Right? In case if you like have another class, maybe hopefully we'll hope that there's no shifting of the schedules, right? In that case, we will be continuing the class on every Saturdays like this, right? But eventually we can arrange some morning classes as well, not recently, but after you go for the grade 13th, right? Once you become the super senior, we're gonna be arranging some extra classes as well, some paper classes and also some revisions. In that case, the class, apart from this class, we'll be arranging another one for a weekday and not getting anything interacted with your current school career, right? Unless they like specifically mention about that 80% attendance. I hope that they will always, right? I hope they won't do much about it. So yeah, anyhow, uh, let's continue today's class. And we were discussing about the projectiles last day, right? So do you have any doubts with that? Yep, about that part that we have finished discussing. Any doubts? Not at all. 39. Okay. We'll stack them together and start discussing. Yeah, what else? 41. 45. What else? Any doubts? Binuli? No? 42. Okay. How about you? No? No doubt? Great. We'll see. Starting with the 39 then. Oh, 39. It's a nice question. Okay, so let's start. So there's a warcraft here going at an altitude of 80 meters with a velocity of 50 meters per second, releasing a powerful bomb. Okay, the effect of the explosion is estimated to be extended up to 100 meters. If the warcraft need to be continue flying horizontally, calculate the maximum acceleration needed to obtain just after it released the bomb. Okay. Okay, some bombing stuffs, right? Don't get mad at me. These are some questions I have extra, not created by me actually. Yeah, some of it, but not this one. uh, okay, we'll see. Great. So it is said to be that the warcraft here is flying at an altitude of 80 meters, like this, right? And releasing a bomb here, we know that it's going into projectile, so it has to be landing somewhere on this spot, like this. And we know if the aircraft also going with the same speed without changing, it's there, right? So it has to be directly above the place where this hits the ground, because why is it so? Why the aircraft has to be directly above the bomb? Yeah, because both of these guys having the same horizontal velocity, so same horizontal displacement for both. Okay, so this was moving with 50 meters per second. So as the bomb then hits on here, and once been exploded like this, the effect of it will be like spreading over a distance of 100 meters, right? You know that once that explosion happens, there are going to be a very big shock wave spreading out. So that effect is there up to 100 meter of radius, actually kind of like a hemisphere, right? In the 3D space, when you think of the above and the surrounding as well, like once it hits on this, right? So yeah. What if the warcraft fly with the same speed? At the time of the explosion happens, the warcraft will be directly above and not in the safe zone. It is now in the because this is to be 100 meters, right? Still in the hazardous zone, because this height will be 80 meters, right? But still, the effect of the blast can have up to 100 meters. So up to this circle, right? Like this. So it's basically asking, uh, just after this bomb is being released, how much this warcraft need to accelerate forward to get rid of the effect. Which means, at the moment the bomb hits the ground, where has to be the aircraft, guys? Yeah. At this point, right? Just beyond the hazardous circle, right? It has to be there at the time the bomb hits the ground, right? At least just escaping out from that, the blast radius, we can say, right? So if it is just can escape out from there, now the warcraft in the safe zone. So we need to find out first the time taken by this bomb to hit the ground, right? At that time, what should happen? The warcraft need to travel from here all the way up to here, right? So it has an initial velocity of 50 meters per second. We don't know what's the velocity here, but this need to accelerate. So in that case, the warcraft will not be directly above the interception point here, right? Okay, so we're supposed to know this distance, guys, from here, from this point. It could be not exactly lying on this radius here. We don't know about it. I'll mark it above. So we need to find out this displacement. I'm gonna mark it as maybe d, right, plus some value from here to here. Put it as x, right? So the warcraft need to fly a distance of x plus d within the time the bomb hits the ground. Got it? Great. Uh, so I'm gonna draw a construction like this. What could be this line, length of this line, guys. මෙතන ඉඳන් මේ line එකේ දිග කොච්චරද? Yeah, it has to be 100. Why? I have drawn a circle here, or kind of like a sphere, which is having the radius of 100 meters. So this also has to be 100 meters there, right? And this is a right angle triangle. Do you know this height? Yeah, it's 80. The Warcraft said to be flying with the same altitude without changing, so it is 80. And if the entire length is D, I can maybe mark here as DO2, or else, yeah, I just go with the here 2D and here to be the D. Then here D and here D. Is there a way to find out the D? Yeah, you can put the Pythagoras. Here it is 80. This is 100. So straight away I'm going to put 60 here. Does it concern? Yeah, it's like this. I think you already know about the Pythagoras triple, right? You can either find it from the D, which is like D squared plus 80 squared equals to 100 squared. That you can do. And find out the D, which is going to be 60 then. Or else, if you can remember about that Pythagoras triple, like 3, 4, 5, and what else? We have 6, 8, 10, 5, 12, 13. Right? All these are said to be Pythagoras triple, which means they are perfectly matching with the three sides of a right angle triangle, where the larger one will be the hypotenuse. If you can remember that, you can do it very soon, right? Or else you can just find it, totally fine. Right? Here it is 100 squared minus 80 squared, and take the square root. That gives the 60. If it is 6, 8, and 10, if it is 6 and 8, we will have 10. If it is 60 and 80, we're going to have 100, right? So yeah, you can find out the D here 60 and another D here again 60. So altogether the 2D is going to be 120. This gap all the way will be 120 meters then. Okay, I'll just go with the like this to reduce the confusion. Okay, great. Then we're supposed to find the x2. Think about a way to find out the x, and all you need to do afterward will be applying a certain formula for the Warcraft. We know the displacement it need to travel, like x plus 2d, which is x plus 120. Initial velocity 50. Time you're supposed to find it. That's the time taken by the bomb to hit the ground. So you need to apply a separate formula for the bomb, and to hit the ground you can take the time from there. What about the acceleration? That's the thing you need to find out. Think about it a little bit, right? I'll give you maybe 5 minutes to think about it. I think you guys see here that the sketching is kind of like a important role, right? Drawing the stuff very clearly and marking the distances, maybe the data. Again, it's good to like sketch it larger. If you haven't drawn it, make sure you sketch it larger and mark the distances properly. Yep, if you are like struggling how I find out the x here, x, that's I think the ultimate question, right? How do you find the x? X is the distance that the warcraft need to go from the moment the bomb was released until that the blast sphere here, right? Which is this gap. මේක තමයි x කියලා දාලා තියෙනවා, right? පොඩ්ඩක් මෙහෙට එන්න ඕනේ. This is the gap x. Well, I could find that one if I know the moment it was released until the bomb hits the ground, which is going to be we're gonna take it to be the range here. I think last day I have mentioned about it, right? Range means the horizontal distance a projectile goes. So here the horizontal distance has to be 200 meters according to applying S equals UT for the bomb. We know the time taken will be 4 seconds. At that 4 seconds until it reaches the ground, it will be moving a horizontal distance of 200, right? So this is going to be 200, and 200 minus this d gives the x. That's what I have written there. But this diagram is not exactly accurate because you're gonna see here this has to be 100, guys. You know, the radius has to be 100 here. So representing 200 will be the Warcraft need to be somewhere here. But it's okay, right? Still, you could find that one out. If you have any doubt at all, at least a tiny doubt, just ask it from me, right? Anything at all. තේරුම් නැති මොනවා හරි තියෙනවා අහන්න. All right, guys. Shall we move to the next one? Okay. Okay. Erasing, right? It's been erased. And guys, don't just make any judge with these questions and the overall A levels, right? You might feel like these are okay, very much hard to try and can't even figure out what's going on. Well, that's totally fine. Uh, Still, it's the beginning, and I'm just encouraging you to not to just do the easy questions. You need to get yourself practice with the easy questions as well, but we need to like consider kind of like next level questions too, right? And if it is a question like this being asked for the exams, unfortunately, it is going to be an MCQ, which you need to figure it out within 2.5 minutes again, right? So not for the very first questions, so don't worry about it. Maybe after 30s or 40s, right? You know that the from 40 to 50, the last 10 questions, the 10 MCQs are going to be a little bit considerably harder than the others, but yet you can try. So it's better to have the practice. It's again okay if you can't figure it out but you by your own. It's totally okay. I'm still there to you for you to guide. But once you get the concept, if you've done the question here, maybe copied it down, that's totally fine. You can just go home and refer the question once again. And මෙතන කරපු question එක ආයෙ ඔයාලා ගෙදර ගිහිල්ලා කරන්න, right? That's why I'm always recommending, right? So up to now the knowledge is kind of mine. I'm kind of trying to deliver it to you guys. It's like watching a YouTube video making a cake by, let's say, Apeyam or someone, right? So she's just telling the staffs, okay, you just need to mix this, and maybe you need to put this much of grams, like that, right? අපි දැන් හදාගන්න හදන්නේ. Likewise, she says, right? රසම රස cake එකක්. Likewise, right? So you're gonna see, okay, once you like wash it, you might think, okay, it's going to be really easy, right? But things come to a little bit weird once you start doing it by your own self. Let's say you are making the cake, start to make the cake. We are not sure how much you need to beat. She's not mentioning මෙච්චර වෙනකම් beat කරන්න කියලා කියන්නේ නැහැ. So ඔයාලත් තමයි ඒක හිතා ගන්න ඕනේ කොහොමද කරන්න කියලා. Likewise, so once you try to do it by your own, you will encounter some practical scenarios that you need to use your knowledge, right? So here also it's something like this. Once we discuss something within the class, still it's going to be a little bit part of from me, and the rest of the part you are kind of figuring out. You can make it by your own knowledge. ඔයාලගේම දැනුම කරගන්න පුළුවන්. ඔයාලගේම practice එක කරගන්න පුළුවන්. ඒ question එක ආයෙ ගෙදර ගිහලා try කරන්න. ඒ කියන්නේ question එක කියවලා අපි කරපු method එක බලන්න නැතුව ආයෙ try එකක් දීලා ආයෙ බලන්න අපි කොහොමද ඒක කරේ කියලා. Within the class we can do only few questions, maybe at most 10 or 15 questions at most, but most of the time it will be just 5 or 6 questions for a day. So just do them once again and start doing the questions given in the theory, right? That's what I'm always recommending. So you can have the handheld practice in solving these kinds of maybe level 2 questions, right? Okay, great. So we'll start with the 41 very soon, because we somehow need to finish up the projectile motion today and also start keen to discuss about the next part too, which is the last part of the motion, the relative motion, right? Okay, great. We'll stick with the 41 then. A ball was shot by blowing to an end of a tube as shown in the figure. That is, glass ball G is there at the point A. Okay. According to the figure, tube is fixed at an inclination of okay. Calculate the value of H. Great. So let me illustrate the scenario. Maybe a simplified version of the diagram. So this is being projected at an angle 45 degrees, the glass ball G at the point A. So I'm going to mark the point A, just the point A. This is the glass ball G. So it's going to go in a projectile path like that. But that seems to be nice, right? Going in this path. At the meantime, another object at the point B, okay. This is point B and being released at the same time. So it's like this. Like this, right? This is the object B falling down and hits on this point. Amen. This is going in a projectile. The A is going in a projectile. At the meantime, the B is dropping. So they're gonna meet somewhere here. So at that time, the B is said to be fallen down to a height of h. While this right here, the glass ball, has been projected with the initial velocity of 10 root 2 and the length of AB line, which means this line right here, has a value of 4 root 2 meters. So I don't need to consider the rest of the motion here. I'm going to consider until it hits at this point. Well guys, I'm just asking you to find out this height. Maybe capital H. Is there a way to find out that H? That you can find out, that's the vertical height that the object has, the projectile here or the glass ball have been reached, right? At the time it has been moved this distance, which is the range. At the meantime, this much of height has been fallen by the object at the B. Is there a way to find out the entire height here, guys? සම්පූර්ණ height එක හොයන්න විදිහක් තියෙනවද? Let me put additional letter here, maybe the E, since it is not mentioned. Can you find out the BE is in this triangle? Yeah. If it is, this is 45, this is also said to be 45, right guys? මේක මම හරියට මදින්නම් මේ තියෙන විදිහට. Right? This is the U, and like this. මොකද කියන්න පුළුවන්? I can consider the A, B, E triangle and I can write sine alpha, sine 45. If I write like this way, will you guys agree with me? Sine 45 will be opposite BE over hypotenuse. Okay with that? Yes. What's sine 45? Yeah. One over root 2. Okay. That's equals to BE over AB. It is 4 root 2. Root 2 cancels off. So the BE distance will be 4 meters. So this entire distance, BE distance is going to be then 4 meters. Then if you could find out this capital H, you could find out the simple H by subtracting with the 4. Since I could write the relationship H equals to H plus H, H plus H equals 4 killian. Then we'll apply some equations for the glass ball G and for the ball C. The confusion here is there are too much of letters, right? Object B and object C and at the point B. That's why it's kind of confusing, right? Point is B, object is C. Here the point is A and the ball is G. That's the idea, right? Okay. Yeah, okay. So we'll start with the maybe the ball, right? The glass ball. For the glass ball upwards, S equals ut plus half at squared, and S is the H, U is going to be the upward component of this U. What's that? U cos 45, U sine 45. So it is 10 root 2 sine 45. I think lastly we have done these kinds of things, right? Basically resolving. Are you okay with the resolving, Tarushi? Really? Okay. Place your arm towards the vector, here the velocity. Bend it towards the angle U cos 45. It is 10 root 2 cos 45. Like that. So what's the other one? U opposite the angle, obey the angle sine 45. Right? Place your arm towards the angle U cos, obey the angle U sine. Okay. So it is going to be 10 root 2. Okay. So for the easiness, I'll simplify this one even further. 10 root 2 into 1 over root 2, guys. Root 2 cancel out. It will be just 10 upwards. To this side, it is going to be 10 root 2. Again, cos 45 is also root 2, if you can remember. And that is also 10. which is pretty easier. Oh, that's minus half into 10 into t squared. Okay, let me simplify this a little bit. 10t minus 5t squared. We'll leave it because we don't know the h, neither the t's. We'll leave it like that. Okay. Then for the object C downwards, still it's going down on the gravity, so it is s equals ut plus half at squared. So that is h equals u is 0. It is dropped. It is dropped freely here, right? So it is 0 plus half into 10 into t squared. Okay. So h is equal to then pi t squared. Okay. So this pi t squared, I can put h there, but I'm gonna have the 10t. Okay. I'm using this. H equals to 4 minus simple h. Put it here. 4 minus simple h equals to minus 5t squared. I can put h. මේ minus 5t squared කියන set එකට මම h කියලා දැම්මා. මෙන්න මෙයා තමයි දැන් trouble maker තියෙන්නේ. How do we replace the 10t? Well, from this one I can have t squared equals h over 5. So t equals to h over 5 root. Okay. So I'm gonna have here 10. Instead of t, I can put root simple h over 5. So you can see the minus h cancels off. So I'm gonna have just this one. This side I'm gonna have 4, and the other side I'm gonna have, luckily, just 10 root h over 5. Great. So this is going to be 10 over 4, 4 over 10 squared will be then h over 5. Lucky me, right? So it is going to be 16 over 100 equals h over 5. So this is 20. H equals to 1.16 over 20, maybe divided by 4. 0.8 meters. So do it. අට්ටිය නිකම් ට්‍රැක් කලාගේ ඉන්නේ නේද? අවුරුද්ද මේ කරපු විදිහ තේරෙනවද කොහොමද දන්නේ? These are basic geometry, right? Maybe you are learning it for grade 10s and 11s. Applying Pythagoras and also writing sine and cos. Right? This is the A-level physics. Right? Shape the, it's okay, right? Just copy it down. If you can't get it, that's also totally fine, right? Just copy it down. නිකන් ලියා ගන්න. And as I said earlier, don't බය වෙන්න එපා, right? 45th question එක කරන්න බැරි වෙයි guys. sorry. අද part එකත් එක්ක තමයි 45th question එක කරන්න පුළුවන්. අන්සර්ද? And guys, while you are writing also, you're gonna see here, I also started from kind of nowhere, right? I also didn't have the kind of proper idea about how to simplify this one. But yet I have written some equations and maybe played with a little bit of geometry. and that's why I have to write it here and there, because I have written one equation and I ended up with some t's here, and to replace that I need to go with another approach. I'm telling this one because you guys also can think about it like that. It's totally okay, right? Write something, figure it out, right? Use your brain. That's how you do it. So I think maybe we could just discuss the 45th one after we finish the part that we discussed today, and also the 42nd one. Maybe I can let you to try again, not now, like having all these idea, and you can think of how this works. And it's totally okay. We'll discuss it maybe on the next day if you can't do it. Right. We'll have a bookmark on this 42 question, not to be discussing now, but try your knowledge, like use your knowledge, and from what we have done up to here, and try it yourself. If you can't do it, we'll discuss it on the next day. And there are a couple of MCQs as well. I think we need to specifically try, but let's stick to the theory first, and we'll finish it off and move into discussing the questions. Great. So last day we were discussing about this projectile motion, and we kind of had the idea if something is being inclinedly projected, how far it goes, or basically the range and the time of flights and so on, right, using a certain question. And I know that the very last moment was kind of a little bit rushy, right? And now it's time for us to discuss it once again and to have a quick recap. So if something is being projected from a horizontal ground, it's going to go in a kind of like a parabolic path like this, which we gonna name as the, can you remember the name of the path, name of the, yeah, the trajectory, right? It's called the trajectory. So it follows the path like this, and we know this is going to be its maximum point of its projection, and that is the h max, or the maximum height. Also, this right here is the maximum, or is the horizontal distance it goes. So I have given a name to be the range of the projectile, right? And this is the velocity of projection, and could be this the angle of projection, maybe the theta, right? The very last example we have considered, this theta was to be 30. Is it 30? The very last question, අපි අන්තිමම question එක බලන්නකෝ. 30, no? Yes. Yes, I have given it to be 30 degrees, and the velocity of the projection was 80. මේ velocity එක 80 කියලා තමයි දුන්නේ. Right. And we have found out these parameters like the h max and the range, right? All these stuffs. අපි last two questions කරාද? Last two parts? I think we did, right? Yes, okay. Time of flight and the project maximum horizontal range. Not the maximum, but the horizontal range, right? Okay. So today we're going to be continuing from there onwards, and we are going to derive some equations that can be used to find out the h max and the range. You know, uh, if you need to find out the h max, it was a whole lot of procedure. Like we need to apply the some sort of equation, and like a kinematic equation, and found out the h max there, right? Basically, I think we first found out the time taken to the maximum height. No, right. We have just taken the maximum height itself. The maximum height එකපාර හෙව්වා නේද? For the second part, I guess. Yes, we have found out the maximum height just applying a certain equation upwards. That's what we did. But you're gonna see, guys, if you go through this tune, maybe to an MCQ. ඔයාලගේ ටියුට් එක බලනකො MCQ ටිකට පැත්තට පොඩ්ඩක් ගිහිල්ලා the questions asking for the projectile. Starting on the page 20. So you're gonna see here, guys, in the very first question, I think I asked you guys to try it. Did I? Yes, I did. About the 63rd question. It is saying that, okay, there was a gun fixed at the 30 degrees inclination to the horizontal and can shoot a bullet with a velocity of 200 meters per second. So what's the maximum height the bullet will reach? Well, you could find it by resolving the velocity and maybe applying an equation upwards, a kinematic equation upwards, and you can find the value of it. Or else, what you could do, maybe if you can deduce an equation to the maximum height, the h max, and if you could remember it, you can apply there straight away, right? Instead of like applying a kinematic equation or kinematic equation, right? Whatever. So that's what we are going to do. And in some cases, you're going to see there, you're going to see in some questions, okay, maybe like this, right? See here, the 80th question, question 80th. The speed u of a rocket at its maximum height is half of the projected speed. The horizontal range. Just asking about the horizontal range. So we need to go along a long procedure to find out the horizontal range, or we can apply there to this equation. I mean, to find out the horizontal range, applying it for any kinematic equation. Or else, if you have a certain derived equation for this one, you could find that one easily. Right? So that's what we are going to do, guys. We are going to derive some equations to straight away find out the h max, time of flight, and also the range. That's what we are going to do. Okay, so we write a topic then. Deriving equations or deriving a relationship. Deriving relationships. We write like that. Deriving relationships. Deriving relationships for the parameters of a projectile. For the parameters of a projectile. Okay, so we write a little note for that. Maybe a point. Let's consider an object. Let's consider an object projected with simple u at theta to the horizontal. Okay, so we'll draw it, and meantime, let's mark the two components. What's this one, guys, again? Can you tell me quickly? What's the horizontal one? U cos theta. Yes, good. So it's going to be U cos theta. What's the other component there? U sin theta. U sin theta. Right? Okay, great. We'll copy down. All right, guys. So we write a subtopic then after this one, right? Kind of like a subtopic, but you can write as a point as well, right? If you need. So maximum height. H max. Okay. So here I could find out the maximum height like this, applying upwards. V squared equals U squared plus 2as. So knowing that the final velocity here is 0 at the maximum point upwards, there will be a horizontal velocity here at this point. So the object is not at instantaneous rest. We have considered about last week, right? At the maximum height, the object will be moving forward yet because of the horizontal component u cos theta, but the u sin theta going to be 0. So upwards, the final velocity will be 0 at the h max, and u is going to be the u sin theta, and we are supposed to square it, minus 2g h max. So you can see here I have applied upwards the equation, gravity works downwards, and that's why this plus turns to minus, right? And I can take this to the other side, then it is 2g h max equals to, the side you can have u squared sine square theta. Well, if you have a product like this, like it's like this, like 2 into 3 squared. So it's like 2 squared into 3 squared. Here u squared sine theta squared means sine square theta. Good, right? Like that. Okay. So my intention is to find out the h max and equation for the x max. So it's very simple. It's going to be just u squared sine square theta over 2g, like that. So either you could remember this equation and apply it to a certain question. Or maybe from the scratch, you can get it from here. If you forget about this one, totally fine. For the moment, apply this formula, which is kind of we already know, and you can still find out the H max. Got it? Great. We'll copy it down. Okay, let's go to the next one. And that's about the time of flight. Well, there are two methods to find out the time of flight, if you can remember. What was the first method? මොකක්ද අපිට තිබ්බ පළවෙනි method එක? Yep. Yeah, you can find out the time taken to the maximum height and multiply it by the 2, which gives the time of flight, right? Time of flight means the total time the object in the air, starting from here, going up to the H max and descending back down and hits on the ground. For that moment, the time taken is considered as the time of flight. So we know that the motion here is kind of symmetric at the H max. So if you could find out the time taken to the maximum height, you can multiply it by 2. And that's what we did last day, guys, if you can remember, right? We have considered about the time of flight was to be calling question time of flight key the time taken to the maximum height is 4, I guess. You have got it to be 4. And you have multiplied by the 2 to get the time of flight. Or else, I think last day I taught you an alternative method that you can do, which means you can apply upwards a certain equation, maybe a displacement equation, and you can make the upward displacement to be 0, because you're going to see here the object is going up and descending back to here, but the actual upward displacement is going to be right here. It goes up and descend back down to the same level, same point actually. Vertically, the displacement will be 0 if it hits on there. Vertical, right? But there will be a horizontal displacement. Vertically, the displacement will be 0. So yeah, you can use both methods. I'm gonna go with the easier one. I mean, yeah, we'll use the first method that you guys have used. That means you can find out the time taken to the maximum height and multiply it by the 2. So for the same object upwards, I'm gonna put v equals u plus at. Final velocity is 0 at the h max. This is 0, right? For the h max, it's better. Okay. Initial velocity is going to be u sine theta upwards. And since I have put it upwards, gravity works down, so it is going to be like that. So t is going to be equals to u sine theta over g. That's the time taken to the maximum height. Therefore, I could write time of flight capital T is equal to 2 times the simple t So t is going to be equals to 2 times this thing, u sine theta over g. So that's the next parameter, guys, we need to find out. Same way that you have written the maximum height, you can write for the next one. Time of flight, capital T. Then write for the h max this and this. Okay, the last equation that we are going to derive will be the horizontal range. So let's try the next subtopic. Same as this, horizontal range. Horizontal range. So that is this R, right? So in order to find the horizontal displacement, guys, I need to consider the horizontal motion of the object. So I could apply S equals ut. Do I need to put that half ATD? Or just S equals T? Just S equals ut, right? Because for the horizontal motion, there's no effect from the gravity, neither from other factors. So it's moving with a constant velocity. So this is going to be the R then. Pretty easy, right? For the u, I should put the horizontal component, which is going to be u cos theta, times for the t, I should put 1. It's the time of flight, guys, because while the ball is just flying in the air, it moves horizontally up to this distance, right? Alright. For the previous question also, we have done something like that. We first find out the time of flight, which is to be 8 seconds. You can refer the previous example that we did last day. See that, right? We have first find out the time of flight, then we have applied the equation x equals ut, and for the time of flight you have found out, you have substituted there the t to be 8 there, right? Similarly, you can substitute that to here, and I could find out the r. Then r is equals to u cos theta. I'll go with the same colors. until I will simplify that. So it's going to be u cos theta into t, which is this. So that's u 2u sine theta over g. Okay. So let me simplify this a little bit. R is equals to, I'm going to have two u's. It's going to be 2u squared sine theta cos theta over g. I could just draw the entire line, or you can leave it like that. Well, I could simplify this a little bit further. If you can remember about some of the equations I taught you earlier about the trigonometry. And the maths guys can figure it out very soon as well. Which means I'm going to have the 2 sine theta and cos theta. Just go back to the vectors if you guys have finished that part, or maybe if you know about it. I think once I explained you how the quadrant works and some ratio that we could write, basically called the trigonometric identities. And I told you there are three identities you need to remember, right? Do you have them? Okay. Do you see something with 2 sine theta cos theta? Yes. So guys, these are the trigonometric ratios you need to, identities you need to remember. One is this one. Tan theta you could find out by sine theta over cos theta. It's kind of a primitive one, right? And the next one is going to be sine squared theta plus cos squared theta is equal to 1. Which means if you put any value for this theta, you can maybe find it out from maybe 45. Okay, so sine 45 squared plus cos squared 45. So what's 45 sine 45? 1 over root 2 squared plus, again cos 45 is also 1 over root 2 squared. So that is 2 plus 2. Half of a cake makes a full cake. 1, right? So you can see here, for any value, this is not just for 45. You can put any value for the thetas, and sine square theta plus cos square theta going to be 1 always. And that's one identity. And the other one is going to be the one that we are going to use, and that is sine 2 theta equals 2 sine theta cos theta. Do you need a counter proof? We'll do. So in a side we'll just do that. Maybe I'm going to take the theta to be 30 degrees. Okay. On this side I'm going to have sine 2 times 30, that is sine 60. What is sine 60? Next time it's really crucial to remember these angles, right guys? Especially that chart. I asked you to display it for a week in your wall, just for a week, right? Not to have it always, otherwise you will end up with looking at the chart always to do a question. So just display it over a week and remove it. Do you guys have that chart? Do you know the values, exact values of? No? Okay. I'll give it you now, right? But you need to make sure you remember them, right? Great. we need to always deal with these angles 0, 30, 45, 60 and 90. Oops. Maybe I'll just draw the third line down. Okay. Could you please close the window? Right. So this is how you read this one: sine 0, right? And sine 30, sine 45, sine 60, and sine 90. Here it's going to be cos 0, cos 30, and vice versa, right? Uh, okay, since we have some old participants, what if we check their knowledge, right? Kind of the memory. What's sine 0? 0, okay. What's sine 30? Half, okay. What's sine 45? Yeah, that's something you have seen, okay. Well, guys, you might be wondering, can't we use that the table that you have used earlier, right? The logarithmic tables. Well, yeah, you could use that, not the logbooks, but not the logarithmic tables in the logbooks, but the sine tables, right? You have referred it for the O levels, looking at different sine angles. You can refer that chart, but we don't have the chart. We don't have that chart always, right? And also, sometimes we need to deal with not just the decimals, but instead some fractions. It's really easy for us to simplify within fractions rather than using the decimals. So you better remember these special angles so you can apply it at any instance, right? Okay, so what's sine 60? Root 3 over 2. What's sine 90 then? 1. How to feel the cos? It's just the opposite, which means it is 1 root 3 over 2, and you can have the same thing for this, right? Sine 45 and cos 45. This is half and this is it. Basically flipping the values, become the cos. Tan is going to be a little bit different, but it's kind of like easy to remember as well. So it is tan 0 is 0, tan 30, 1 over root 3. What's tan 45? 1. Tan 60, root 3. Tan 90. Yeah, actually it has to be not defined, but for the physics we can learn it as infinity, right? Infinite. Okay. Great. So these are the values you need to remember. It's very easy, right? It just has a certain pattern here. You can see it's one just root just 2, and then root 2 vanishes and root 3 appears. And it's the opposite of that. Here 0, 1 over root 2, root 3, and 1, and the root 3 comes up. Something like that. Right. These are really essential to remember. Okay, we'll copy down that if you don't have the chart, and if you wasn't there for the vectors, guys, it's again it's better you could finish up that 8-hour class, right? Not the class actually, but the 3 classes merged to be 8-hour video. And still you're gonna have some time to start the schools. Maybe some schools have been started. If so, this is the coming week is the vacation for you, I guess. So make sure your vacation is kind of worth enough to cover up a beginning part. Maybe you can spend 2 hours for a day. It's going to be just 4 days then. Right. So we were somewhere here. I was just proving this to be valid. Did they mention anything about the school start? No idea. I think the third week, and most probably the Wednesday of the third week. Okay, okay. Maybe they will inform you via letter, maybe, or maybe they will just call you. Yeah, okay. This year, I think there will be around 35-ish some students. So that's probably going to be the highest intake since for a longer time. In our cases, it was just 20 people, like 7 doing combined, and the rest of the guys are doing bio. 22 actually, yeah, 22 people were there. Finish with this? Great. Uh, Again, guys, make sure you remember this. It's okay to refer the chart today, but you need to have it in the mind. Raising this one. So we were proofing that one, right? This thing right here. So I'm taking the theta to be 30 and substituting the values. I'm going to show you that this is working. And sine 60 is what then? Root 3 over 2. I'm going to go to the other side, which means to the right hand side. Not to do like that, but okay, fine. So sine I'm taking as 30. So sine 30 cos theta cos 30. So 2 into sine 30 is what? Half. That's cos 30 root 3 over 2. And 1, 2 cancels. So yeah, it works. Right. So I'm gonna have it to be same as the left hand side, guys. So these are called trigonometric identities. And for the maths guys, there are going to be a whole lot of it. But for the physics and for the bio students, maybe moreover all the physics students, you need to remember only these 3 identities. That's all. Right? So this I have given once. But if you don't know about it, make sure you write it closer to the table that I have given you now. If you can remember it, then don't worry. And guys, since we need to deal with these root values, you're supposed to know about these two. And again, I have given this. Root 3, we're going to have in that chart the root 2's and root 3's. And we're supposed to know them at least for the second decimal place. So you can substitute easily. Also, we're going to need to learn about the root 5 and also the root 10. What's root 2? 1.414. But it's again okay remembering up to the second decimal place, right? Decimal place of the This is what? 1.732 is 1.73. Root 5, 2.24. Root 10, 3.14. Roughly equal to the value of the pi. 22/7. So make sure you write those values as well, and you need to remember them. Oh, right? Okay, so now we are back into here. And all I'm trying to do here is simplify this one a little bit and write an equation. So it is going to be u squared over g. I'm going to write 2 sine theta cos theta. Writing this 2 with the other sine theta and cos theta. So I'm going to have u squared r equals u squared over g, and this is sine 2 theta. This is the other equation that you could use. Kind of a simplified version of just having a sine, because we're going to have two angles here, sine theta and cos theta both. You can simplify it to a single sine value, but 2 theta. And guys, it's okay if you forget about these equations like the h max and time of flight. You can just derive it from the scratch using these formulae. But it's better you could always remember the horizontal range, because we have derived it from like finding out the time of flight and substituting it to here, and even simplifying maybe by few steps. So it's better you could just maybe highlight it or maybe like put a star mark and remember these equations rather than the other two. Keep it there, මේක අපි derive කරගත්ත ටිකක් අමාරුයි. So remember it, because you won't be getting some time to derive it if it is an MCQ being asked. Rather than these two formulae, make sure you remember these. මේ දෙක මතක තියාගන්න අනිවාර්යෙන්ම. Crucial rather than these. Alright guys, next thing is, how can I just maybe maximize the range here? If I need to have the maximum range, what are the parameters that I could change? Maybe I think you have seen uh, in some real life scenarios that we need to have a certain maximum range. Where are the places? අපිට සමහර instances තියෙනවා මේ range එක maximize කරගන්න වෙනවා from on a projectile. මොනවා වගේද? Unless you are like hitting someone, right? Any crazy ideas? A slipper from your mom is going to be okay in a projectile, but yeah, that also can be maximized. There are some competitions as well. What about the putt shot? I just need to throw it like that. Oops, my wind cover has blown out. Yeah, in those cases, we just need to have the maximum range to win the competition. It's a projectile, right? Butt shot is going to be a projectile going like that. Heavy but a projectile. Then what are the other cases? High jump. Just need to maximize the range. Not the high jump, right? Actually, the other one. What's that? The long jump. Yes, sorry. And you have a long jump, right? You need to maximize the range. Maybe a javelin. Again, you need to maximize the range. That's kind of like some competitions, but when it comes to like attacking or maybe like hitting on an enemy camp, or when using the projectiles for the bows, they also need to maximize the range to have much effect, right? Okay, so thinking about this, making this R to be maximum, what are the parameters that we could change here? What can you say about the G? Can we change the G? No, unless you go to maybe the Saturn or maybe any other planet, you can't just change the G, right? It's kind of like 10 meters per square second fixed. Then what else you can change? You can change the U, which means the velocity of the projection, right? And that is why you have seen, guys, the people who are like putting that putt shot, right? They gonna like if there's a strengthier person, he can just throw it with the initial higher velocity. This U can be maximized. This can be maximized, so it will be increasing the range. Maximize the range too. U එක maximum කරන්න එකේට පුළුවන් මේක 10 meters per second throw කරන්න. තව එකේට පුළුවන් 20 meters per second. Another one can throw it with 100 meters per second. And when it comes to, let's say, it is like a gun that is maybe shooting some bullets. So the initial velocity will be depending on the firing power of the gun. That could change from gun to gun, or maybe from this instance, right? So you're gonna see here, there's no any limit for that one, for this U, right? There's no any fixed maximum value. Maybe it will be determined by the person who's throwing the projectile, or maybe it's determined by the machine or whatever gun like that initiating that projectile. It just depends on the equipment or the person, and there's no any maximum value for that, right? One can throw with 10, the other can throw with 50, or maybe 100, thousands. Likewise, there's no any fixed maximum limit. Yeah, you can maximize this U, but there's no any proper limit for that, a higher value for that. Then the other thing is the theta here, guys. Theta is what? The angle of projection, right? I'm going to show you from my simulation, which I have used earlier, change in this theta, how we can have the range be affected, right? So if I just show it to you, I can just maybe throw it up like this. So it's going to be directly going up and down, which is not a projectile, by the way, it's just motion under gravity. But I could just throw with a higher angle, maybe like this, right? It has been gone a little bit for maybe to this level, or else I can project with a smaller angle, maybe somewhere here like this, with the same inclination, like that. In that case, it seems to be going a little bit further, and let me kind of visualize the concept in much a detailed way from the same simulation which we have used earlier. So I'm going to go with full screen. Okay, I'm going to go with the lab, and like that. Great. So this is my canal here. I can just change the inclination for whatever the value that I need. So I'm gonna start with a very small angle. Theta පොඩි angle එකක් දීලා පටන් ගන්න. I have given there just the 10 degrees, so 20 degrees here, like that. And giving the initial speed to be, let's say, 20 then will be 20 meters per second. Okay, I'm gonna shoot it then like that, and let me zoom it out. So this is my range, which is around 30 meters, actually 30.8 meters, right? So what if I increase the angle here? May angle එක increase කරොත් මොනවා වෙයිද? Will it be increasing the range? Theta increase කරොත් what happens to the R? Decrease? We'll see. Right? So I'm now at 20. Let me make it up to 30. Okay, now I'm at 30. Let's shoot like this. So you can see the projectile, the range has been increased now. It was earlier at 30.8. Now it is going up to around 38-ish, right? Somewhere like. I'm going to increase it a little bit further. Notice here, guys, I'm not changing the initial speed, which is always 20, but I'm just changing the angle. I'm going to go with 40, guys. 40, okay, 40. Oh, what can you tell? Have a lucky guess. Will it be increasing? I have increased the theta now. Earlier I have increased it from 20 to 30. You can see the increased range. Yeah. Any guess? Decrease? Okay. What else? Decrease? Okay. Let's shoot. A little bit even further, right? You can see it's still increasing. So why you guys tell it is to be decreasing? From the perspective of how I throwed it. Okay, great. Okay, so now we add 40. Still you're gonna see the projectile, the range has been increasing with the angle here. Let's do it even further. Maybe I'll go with 50. 50? Okay, 50. Okay. But you're gonna see there, it has been decreased a little bit, right? Now. Okay, maybe going with 60. 49, 50, 60, come on, okay, 60. Going up, okay. Now you're gonna see the projectile, the range has been now decreasing. So it's not the magic that once this theta increases, this always increases, right? We'll go even further. What about 70s? Okay, 70. I wish I could touch it there. Okay, sorry guys. Okay, 70. Okay, what has happened? Now the range is even dropping, right? Maybe I'll go with the maximum of 80 as well. Now the range is very slow. I mean, very small here. Here it's around 14. But you're gonna see something noticeably increasing here, which is this height. compared to the other ones, right? So the thing here is, guys, when you're gonna go with smaller angles, which means these smaller angles, when you like decrease the u, what's gonna happen? You know that these two are the two components, yeah, and those I have represented like the two shadows, right? The horizontal shadow and the vertical shadow. What if I just lower the angle? What if I lower this angle, guys? You're gonna see the shadow, the horizontal shadow going to increase its length. If I increase it more, this shadow, the length of that shadow is going to decrease, like that, right? Which means for smaller angles, the u cos theta going to increase, but the u sin theta going to decrease, right? I'll draw it for you guys. අපි angle එක පුංචි කරනකොට like this. Can you go with a smaller angle, maybe like that, a smaller theta? In that case, u cos theta is going to increase, but the u sin theta is going to be just this height. Then what happens? You're going to have a lesser vertical velocity and a greater horizontal velocity. So when you're going to go with smaller angles, the time of flight will be lesser because it's not going up to a higher distances. Now you're going to see here, see, I have projected with 20 and this is the path of that projectile. It's not having a good height here. ලොකු height එකකට යන්නේ නැහැ. If it is not going to a higher heights, what should happen? Lesser the time of flight. So even though it's having lesser time of flight, the horizontal velocity is higher, so it can go a longer distance. So you're gonna get the path of the projectile to be like this. I'm gonna erase with the H max, right? But if you go with a higher angle, maybe like this, then, or maybe even more, maybe 80s, I'm going with 80s. Think about the shadow, guys. Now the horizontal shadow will be this much, while the vertical shadow will be greater. So if I say with the specific terms, the horizontal velocity or the horizontal component here will be lesser in that case, but the vertical component is going to be higher. So that's why you're going to see it's going for some sort of greater heights rather than the other one. මේකට වඩා ලොකු height එකකට ගිහිලා තියෙනවා මේක. Because of the upward component to be higher. But even though it is having a higher height and higher time of flight, it's going to have a smaller component to the front, which means it can't go higher horizontal distance. So going with smaller angles is going to increase the horizontal component, but it has a lesser time of flight, which means it can't go higher distances, higher horizontal distance. Going with higher angles, the vertical component is going to higher, so it increases the time of flight, but the horizontal component is less there, so it can't go even to a greater range or greater horizontal distance. So which means we kind of has a certain maximum value. You're gonna see there, guys. First it was increasing and thereafter it was decreasing. There will be a maximum value for this theta to make the R to be max. Okay. That's what we are going to find out. So we'll start with writing some notes. After you copy down after here, we write underneath even though it is projected, even though the object is projected, even though the object is projected with the same simple u, with the same simple u, the angle of projection, the angle of projection theta, the angle of projection theta changes the capital R, changes the range, capital R. Okay, we'll draw this one, guys, now. And guys, mark somewhere with another color. There's a maximum range that we can have. So our intention is to find out this R max. Also, what's the angle for there? Right. Okay, great. So we write it below with some points, right? We write the first point. If the theta, if the theta having a higher value like 80 degrees, if the theta having a higher value like 80 degrees, 80 degrees, 80 degrees, the vertical component of the U, the vertical component of the U will be higher and brings the object to higher heights, increasing the time of flight too. But the range is lesser. Due to a smaller horizontal component. Due to a smaller horizontal component of U. Due to a smaller horizontal component of U. Maybe you can mark there. I'll put a reference. You can maybe put 1 and put 1 there. I may refer kare are ए वगे का. Theta is having a higher value, right? Maybe go with the next point. We write the next point. If the theta is smaller, like 10 degrees, if the theta is smaller, like 10 degrees, the time of flight, 10 degrees, the time of flight will be lesser. Time of flight will be lesser due to small vertical component. Due to small vertical component. Vertical component resulting a lesser range. Even though the horizontal component is higher. You can maybe write some abbreviations like the horizontal component like HC and VC if you need, right? So we are now kind of referring to a scenario like this. In this diagram it's like this, but in my case I could mark here the 2. You can give the reference to be 2. Guys, seems like exhausted. Why is it so, guys? Don't worry, soon I'll fixing a fan to this class. and also some ventilation, right? Okay, great. So we write the third one. The range will be maximum. Next point. Next point. The range will be maximum. Range will be maximum. Hold there and see the board. So I need to maximize this R. So I can't just maximize the U. You have seen the reason, right? It's not having a certain limit. So I could maximize the entire uh, sine 2 theta. What's the maximum value the sine can get, guys? What's the maximum value a sine can get? Value of the sine, not the theta. Theta could be 90 or whatever. Any maths, guys? Just description. Are you guys doing bio? Maths? Bio. You said bio? You too? Bio. Okay. Seems like you are the only person. Then don't worry again, right? Tell me how the graph is. Okay. Right, guys. So up to now, then okay, anyone can answer this one. Up to now, we know some values for the sine, right? Sine maybe like 0, half, likewise. In that chart, refer it and tell me what's the maximum value the sine got. Yeah, it is 1, right? Because all the other values, even though it is 1 over root or 2, root 3 over 2, think about the root 3 over 2, which is sine 60, guys. It's going to be 1.732 divided by 2. That's going to be again 0 point some value, right? It is 0 0.8 here, and so on. Not 8, 8, 8, 6, and 6, right? So every value you have obtained always will be lesser than 1. And there was a point where the sine gets the maximum of 1. So the maximum value the sine can go is just 1, guys, then. So if you draw a graph for the theta, sine theta versus the theta for different angles, we already know sine 0 is 0. Sine 90 is what? Plus 1, right? And you can see thereafter this is 0 and this is going to be minus 1. And the graph will be looks like this. Of course, we can go with higher angles too. So this is called a sinusoidal variation, how just the sine varies. So your graph will never exceed this plus 1 and also the minus 1. Right? Always your sine value will be bounded between plus 1 and minus 1. So the maximum value the sine can get will be 1. Not the angle, but the overall sine value. You have seen the sine value will be increasing from 0, then half, then 1 over root 2, then root 3 over 2, then 1 when the theta becomes 90, right? So that's why I have drawn here. When theta equals 90, sine theta going to be 1. That's what I have drawn from this graph. Okay, so I have maximized the range. Then R max is equal to then U squared over G. This gives the maximum range, guys. You just need to square the initial velocity of the projection. Here in this case it is just 20, or whatever the value U. Square it and divide by the G gives the maximum range. What's the angle? මේක දැන් අපි හොයාගත්තා. Angle එක මොකද්ද? To become the sine to be maximum, which is 1, it has to be 90, right? Okay, so it's like this then. Sine 2 theta maximum max equals 1. Do you have a way to write the 1 from the sine? Yes, you could replace with sine 90, isn't it? Sine 90 and 1, so you could replace the 1 with sine 90. So it is sine 2 theta equals sine 90. You can just cancel out the sine and sine here. There's a whole lot of procedure that we need to find out the general solutions for the theta, and they're gonna learn it very soon. Something like this: theta equals to n pi plus minus 1 to the power 2n, sort of an equation is there. But we don't need to do that. Here we're gonna have sine 2 theta, a certain angle, is equal to again some sine angle, which means I could write what? The 2 theta has to be equal to 90. මොකක් හරි sine value එකක් angle එකක් තියෙනවා නම් ඒක මේ වගේ angle එකට equal වෙන angles දෙකත් equal වෙන්න බෑ නේද? So I could have theta equals 90 divided by 2, that is 45 degrees. So if you project with the exact angle of 45, you are going to have the maximum range. Let's see if this works. So you're gonna see here, this was the 30 projection, and I'm gonna go with 45 now. This is 45. Okay, let's see if it works. Right, you're gonna see that is the maximum point where we hits, right? ඊට කලින් කීයටවත් ඒ point එකට අපි hit කරන්න බැරි වුණා නේ. So this is going to be the maximum horizontal range. If you need to have a certain maximum horizontal range without changing the u, what you should do? You should throw with exact angle of 45. So either you can go to a gym, make yourself fit enough, and throw the putt shot with a higher velocity, or else come to a physics class like this, learn how the physics works with the projectile, and throw with exact angle of 45 and having a less velocity. You don't need to increase the velocity here, right? It's the same value. But if you project with the certain correct angle of 45, that's gonna go to the maximum range. Got it? Great. So that's what we are going to do. We'll write it. We write like this, right? B. Leave it at neither. We'll fill in the blanks. What's that? Range becomes maximum when theta equals 45 degrees. Okay, so yeah. You might be wondering, can't we use this equation? Well, yeah, you can, but you need to deal with both ratios here, sine and cos. Instead, going this equation will be very easier. So all you need to do here is just write this. R equals to U squared over G sine 2 theta. Right? Go like this. Once you get this one, cage it, and thereafter write for the maximum range. You can write sine 2 theta max equals 1. And maybe using a pencil you can write sine 90 equals 1. That's why I have replaced the 1 with sine 90. And this will be a side note. Just sketch the graph somewhere, corner. Case that theta equals 45 as well. Guys, we forgot to write the reference for the R max. This is the third one. අර ලියපු third point එකට reference එකක් දාගන්න 3 කියලා. Kindly when theta equals 45, range is maximum. And yeah, we'll just mark the 45 too, guys. Don't increase the size of the arrow. It's just the same U. But make sure you mark the 45 like this. Okay, great. So with that, that's kind of like the end of the all the theories that we need to know about the projectile. So next thing remaining is to us to try more questions, right? That we're gonna do after 5-minute break maybe. Now it's 5 to 3. You can have the break until maybe 3:02 or maybe 3:05 at most. Yeah. Then we'll be continuing the class until 4:30 if it's okay for you guys. Are you guys okay? Okay, great. So yeah, we'll be continuing until the 4:30, doing some questions with the projectile motion and hopefully move into the next part too, the relative motion. Okay, we'll have the break. We'll discuss some of the questions, starting with some MCQs. We'll do. Okay, guys. So, what about this 87th question MCQ on the page 21? 87th question on page 21. තියෙනවනේ. යාන්ත්‍රික දෙයක්. හරියට තියෙනවා. What's the answer? 2560, no? How do you get it? Well, we know that R max equals U squared over G. So you could find that one by 16 squared, so 160 squared over G. That's 10. So 60 into 62, 56, and 2 zeros, divide by 10 meters, right? So what can you tell, guys? Should we need to remember this equation or not? And if you say no, you need to derive it from the very scratch, right? I mean, you just need to find out the time of flight, then the horizontal range, and thereafter you need to maximize it too, and to get this. Right? See here, it's very crucial to remember uh, the range equations and also the maximum range, other than all the other things, because they can be found out very easily. But here, these questions, we need to know about the equation, right? Okay, great. So what about the 90th MCQ? 90th MCQ on page 22. Well, it's okay, guys. You can write in the tune, but just have the practice to use a rough sheet when even you are doing an MCQ. because writing things in a nice spacious space will help you in figuring out the things. If you write it in a very short space, you will have less visions in that case, right? So it's asking about the maximum height projected. Oblique means that the projectile curve, right? The orbit parabolic path, which means it is kind of slanted and projected. Yes, guys? Didn't it? Got an answer? No? That is okay. You can apply it for that H max thing equation we have derived. Ali? Is it u square sine square theta or 2g? Eh? Yes. It's theta. 45. Why? Now it is reaching the maximum horizontal range. That's where the theta has to be 45. Oh, guys. බලන්න කොච්චර ලේසිද කියලා. If you forget about this one, that's totally fine. You can just apply upwards. V squared equals u squared plus 2as. You can find that. H max. Okay. So even you don't need to find this u, just u squared substituted, right? Shall we try maybe two more MCQs? Okay, so what about the 89? 89. Saying about an insect. Come on guys, pretty easy. This is the insect. Right. Okay. So it can fly, not fly actually, it can just jump with a certain velocity. We don't know that, but it's given that the maximum range, the R max, it can go is 0 0.2. No, not much, right? Just 20 centimeters, toing like that. 20 centimeters, right? Okay. So, yeah, you can find out u from that. So, R max is 0 0.2 equals u squared over g. So, u squared then again equals to 2 meters per second. Oh, there's something wrong with the power here, right? It has to be meters per second, guys, not s. Right? Estimate in meters per second thing. The speed at which it moves forward without stopping on the ground. Okay. So which means without stopping from the ground. Mhm. Which means it should fly horizontally, right? Yep. So this is 0 to meters. Okay. All right. So u is going to be then root 2 meters per second. U squared is 2. So this is root 2 meters per second. What's root 2? 1.41, right? Meters per second. Yeah. So how do we round it off? To 1.5 or 1? You don't see a value with 1 point. You're gonna see here we have 1 or 1.5 or 2. What is that round off? Maybe you need just correct the unit, guys. Sorry, it has to be meters per second. Yeah, you should round out if to 1. Why? Because this is lesser than 5. If it is 5 or greater than 5, we're gonna round off to the next decimal, this next whole number. So it has to be 1 meters per second, which means it is asking if it flies horizontally. This guy flies horizontally. What could be its velocity? That's what it is asking. Unless if it is a flying cockroach, right? I also don't like that. Okay. One more question we are going to try, guys. And that's about this question. Maybe two questions. That's it. Two questions, right? 80 and 88. 80 and 88. That's all. MCQ 80 and 88. Answer has to be the third one. No? කොහොමද ගත්තේ කියන ප්‍රශ්නය. See here guys. It is not asking about the maximum horizontal range, right? It's just asking what's the horizontal range. Right? So you don't need to take the R max. Right? Here it is saying that the range here, horizontal range is H. So we just write the range equation. Right? And we need to know, either you can write that sine 2 theta thing, right? මේක ලියන්නත් පුළුවන් R equals U squared sine 2 theta over G. So seeing at these answers guys, you don't see the theta. Theta and also something that we have put by our hand. That need to cancel off. Theta කියන එක අතින් දාගත්ත කියන්නේ නේ. Cancel or we need to find it out. Either you can use this equation or maybe this. For each scenario, we need to know the theta. And we have given another data here, which is the speed of the rocket is u. The speed u of a rocket at its maximum height is half of its projected velocity speed, which means it is projected with the u at the maximum height. The projection, the velocity is u over 2, half of that velocity, say like that. So think about guys, at the maximum height what becomes 0? The vertical velocity becomes 0. That means whatever there will be a vertical component, which is the u sine theta, becomes 0. But still we're gonna have what? U cos theta. That doesn't change, right, all the time. So at the maximum height you're gonna see only the horizontal component, and that is the half of the initial velocity of projection, which is u. So here it is u over 2. U over 2 becomes what? It's the same u cos theta. So the u's cancels off, cos theta will be half, and I can take the theta cos inverse half. Half is given by, you can refer the table if you can't, still if you can't memorize that, right? But make sure you do it very soon. So it is going to be 60, because 60 is half, right? So you can put it to here, but you're going to end up with sine 2 theta 60. So it is be 120. Sine 120. It's somewhat hard to find, but totally okay. Recently I have taught you about, in the vectors lesson I have taught you about, if the angle is higher than 90, how we can take it. There are some couple of conversions that we can do with the quadrants. Well, you're gonna have sine 120 here. R equals, if you use this equation, it's going to be u squared over g sine 2 theta. Theta is 60. So 2 into 60 is 120. Then you could write this one by maybe sine 90 plus 30. R equals u squared over g. Likewise you can do, right? මෙහෙම කරන්න පුළුවන් විදිහක් තියෙනවා. 90 plus කියන්නේ we are the second quadrant, right? So we are the second quadrant, and I think yeah, it's there. 90 plus means we are turning it to cos. Sine 90 plus theta is cos theta. But we should think of what is the ratio and put the sign plus or minus. So this is plus, isn't it? Plus the thing. Yes, yes. Okay. So you could write R equals u squared over g sine times cos, then cos 30. You can write it like that, or else apply this. Without that 2 thing, right? 2 theta, we have derived this first and simplified it up to here. You just use this. And guys, I think it's better you could just go through the vectors part once again uh, to see how the conversions with the angles. Then you can substitute it to here. Sine 30 is root 3 over 2, cos 60 is half, 1, 2 cancels off, and it's going to be root 3 u squared over 2g. Okay guys, I think that's kind of uh, yeah, we'll just finish up this part, maybe without trying that 88th question, leaving you for a homework, right? Not just 88, you can try all the questions from the projectile motion. I'm leaving you guys to think about it, the 88th question. Sketch it and write it there. And again, I'm mentioning here, even though you are doing an MCQ, I know that it's, you guys also think of, all right, so this is supposed to be a very small question. Well, no guys, you're gonna see here we need to do a whole lot of simplifications. So make sure, even though it is an MCQ, don't, it's okay to write within the tute, but you don't have sufficient space to write there. So make sure you use another paper or whatever, sticky note or something, right? And do the MCQ there, maybe in the book, right? Try within your book, the book that you use to write do the questions in the tute, right? අපි tute එකේ දෙන questions ටික try කරන පොතේ ලියන්න, right? Take much space as possible, like draw the idea, like draw the scenario, then you will be, it will be easy for you to visualize what's going on. Okay, so for the last, in concluding this part, I just need to show you something a little bit funny as well, right? So what I'm going to show you, it's a funny video that is made by, not actually funny, but yeah, sort of, right? So it's a video made by the engineering faculty guys from University of University of Ruhuna, maybe quite long ago, but I just need to show you a specific part of that video, right? So it is this. I don't know whether you have watched this one already. It's a funny one, so disclaimer there. Have you watched this before? No? It's like just a remake of a audio, right? Do you know what he's playing? No? It's about the Angry Birds, right? So have you played the Angry Birds before? Like just throwing something at that piggies and they're gonna just fall down, right? So you're gonna see here, this guy is doing something. What is that? So he just calculated the range of a projectile here and using a compass. So it's just like a projectile, right? In that case also. So he's saying like अंतिम मस्ती को serious करेलो, right? Just doing the calculation and shooting a projectile. Because if you can find out the range there, you need to know, right? You need to get. You can measure the angle, you know, this is the range. And measure the angle and project it with that velocity. So, kind of a funny thing, but I just need to mention. To give you the idea, don't think this one to be like මොහරි අමාරු මේව, right? Not like that. Right? අර නිකන් fun එකේ වැඩේ කරගෙන යන්න තියෙන්නේ. අර when you do a question, it just take it easy, right? Just draw it, mark the data, and write the equation maybe in a side. Then you're gonna have a certain vision. Okay, that's how you do it, right? Then yeah, it's going to be easier then. Right? අර අද මේ කරපු ටික නිකන් එනවා අමාරු වගේ දෙන්නේ සමහරවිට but totally okay. අර sketching part එක තමයි පොඩ්ඩක් කරගන්න. ඊට පස්සේ some equations you need to do, right? So start with the unknown, right? දැන් මම උනත් මේක දැනගෙන හිටියේ නෑනේ. නිකන් මේ questions මම දාපුවා තමයි. I know that. But I'm not like kind of memorizing each and every question. So just reading the question, sketching it. Yeah, okay. So that's how we do it. Right? Okay, great. Yeah, so with that we can, since we have a little bit time left, around 30 minutes, we'll move into the last part of the motion. As I promised, we're gonna be doing the relative motion. I'll share this entire video if you need to watch it. Maybe in a side time. Okay, so we write the topic relative motion. So, what does it mean by relative? Something relative. It's a motion. I have a relative one. Yeah. Relative කියලා කියන්නේ මොකද්ද? Yeah, you're gonna also express the things. Doing a certain comparison maybe, right? That's the overall, I mean, kind of like basic idea of what's a relative means, right? Relative means we are doing a certain comparison and expressing something, right? Maybe you can express the price of the books that you have relative to the price of the books which were maybe 3 years ago, right? So in that case, you are referring to the old value and the new price, or the price and the new price and giving us a relative idea or comparative idea about that. In that case, is the price of the book. Here, what we are going to do here is like expressing the motion of a certain object relative to another object. Right? That's what we are going to do. Okay, that's something like this. So let's say we're gonna have a certain bus. Nowadays we're gonna have the new buses too, right? So let's say this is to be an we'll just go with the Ceylon Tangerang buses, right? So just SLTV. By the way, it's the Sri Lanka Transport Board, not Tangerang bus, right? TV. Right, okay, so yeah, so this is the driver. Yeah, okay, we'll just not draw the driver. Maybe a passenger here, just sitting and chilling, right? Of course, for the CTV buses, you can't chill, right? Okay, and I'm just erase this one, the logo. And on the same flow, let's say, okay, great. Okay, so there's another person maybe. Maybe walking forward. Let's say with a certain velocity, maybe 2 meters per second, like that. Yeah, okay, so let's say this is the conductor, right? It's just going forward, ticket gana, like that. Right? Walking with 2 meters per second velocity inside the bus. This is just a passenger, an innocent passenger, right? Like this. And let's say the bus itself is driving with a velocity of 20 meters per second. And all these are happening inside the bus. And let's say we could see them through the shutters, right, through the windows. And there's a person here on the ground. Right, kind of. Oh, hold on. He's just looking at here. Sorry guys, I'm not good at drawing. Okay, maybe like he's looking somewhere there. I'll draw that face. Okay, whatever. This is the legs. Okay. Okay, fine. This guy right here just observing the things. Maybe I just draw it like this. Come on. Okay, great. Right, so this is his hands. Okay, hands. Hands, okay, fine. So this is the earth, let's say. Or maybe a certain observer on the earth besides the tree. Right? So how many uh, people are there? Just three, right? So guys, uh, we're gonna see here, if you look from the earth this guy is at on this chair, right? And this conductor is just walking on the bus, and the entire bus is moving forward with a velocity of 20 meters per second. Right? And let's suppose that the entire bus is not having too much of curtains and everything, so you don't see anything outside. All the shutters have been closed, right? You get that weird feeling, right? Charter scene, right? Bus එක මොකක්ද පේන්නේ, right? All the curtains are being closed and shutters are also being closed. So you are not seeing what are the things happening outside. Instead, you only see the conductor moving forward with this velocity. And let's hope that this is not in Sri Lanka, unless you feel like the bus is kind of bumpy because of the roads, right? Let's consider it to be a perfect highway and you don't see anything outside, right? So just go to that scenario, and in that case, guys, is there any clue that we can say that the bus is moving? බස් එක ඉස්සරහට යනවා කියලා ඔයාලට ප්‍රූව් කරන්න එකක් හරි දෙයක් තියෙනවද? You don't see anything outside, and you don't feel anything that the bus is kind of shaking or like that, or you don't hear any sound noises of the engines. In that case, no, right? You can say something moving if you see outside and the trees and buildings are moving backwards. If it is so, you can say, okay, the vehicle I am right now is being moving. If you don't hear any sound of engines, if you don't see anything outside, you are an object that is moving, but you can't confirm that. Still, you're gonna see within that bus there's a person moving forward. That's the only observation that you can make, right? So guys, relative to you, this conductor will be having a velocity of 2 meters per second, correct? But now let's open up all the curtains, and what this guy will see, person on the earth, he will see that the bus is moving with that playing that Dumba Charlie music, right? Bus is moving forward, and in the meantime, there's the conductor going forward as well, right? So, relative to an observer on the earth, the bus seems to be moving. Also, at the same time, the conductor is moving. If you go into this bus, this guy was at rest. If all the curtains are and everything are being closed, and this passenger is retaining on his heels, so he don't see anything outside, so he's just sitting on the chair. So relative to the bus, this guy is at rest, isn't it so? So relative to the bus, this conductor is moving with 2 meters per second. So what I need to say you here, guys, depending on the perspective or depending on the observer of looking the motion, it's going to have sort of different velocities for each and every object. So with respect to an observer on the earth, you can see the bus is moving, also the conductor is moving with 2 meters per second. Also this passenger is also moving in the same 20 meters per second. Additionally, the conductor will be moving a little bit higher with a higher velocity than this 20 meters per second, because this observer on the earth can see the conductor is moving within the bus. If you go into the bus, and let's consider about the B or maybe the A here, what does this A see? AC means A sees. ඒට මොනවද පේන්නේ? The observer on the earth sees that the bus and the passengers and everything are moving forward. While if you just go into the bus and sit on the chair, what do you see? This E and the tree is going backwards. So, මම පොඩි කාලේ හිතුවා ඇත්තටම මොකද මේ චූටි කාලේ මම ඉස්සර බස් වල යන්න හරි කැමති නෑ කෑ ගහනවා right මම බස් ගන්න මම බස් අරගෙන බස් එක නැගපුවල ඉඳන් කෑ ගහන එක කරන්නේ පොඩි කාලේ ඒ කියන්නේ මට එන weird දැන් මේ සාමාන්‍යයෙන් අපි ඔක්කොම forward නේ ගිහිල්ලා තියෙන්නේ බස් එක නැග්ගම ඔක්කොම backwards නේ යන්නේ කියන එක හරි ප්‍රශ්නයක් so ඉතින් පොඩිම කාලේ ගොඩක්ම චූටි ඒකට ඉතින් ඒක තමයි මට තියෙන ප්‍රශ්නේ ඉතින් ඒ දවස්වල relative velocity තරගෙන හිටියේ නෑ නේ දැනගෙන හිටියා මම හරි ගන්න තිබ්බා හරි So, which means, guys, relative to the frame that you are in, that's the specific term that we need to use here. It's called a reference frame. Relative to certain frame that you are in, the motion of the other objects are going to be different. මෙයාට පේන්නේ බස් එක forward යනවා වගේ. බස් එකේ ඉන්න කෙනෙක්ට කියන්නේ trees and every buildings are going backwards. Right? At the meantime, this gonna see the conductor just moving at 2 meters per second, but the person on the earth sees that the conductor is not moving at 2 meters per second. Instead, along with the bus, it's actually moving at 22 meters per second. 20 plus the additional 2. Right? So, things are going to be a little bit complex when it comes to reference frames or the frames which are moving. So if there are objects which are in motion and relative to that object, if you are describing another motion, we are using the concept of this relative motion or relative velocity. There's a specific principle that we can use there, and we are going to learn these kinds of concepts. Right. Okay. Again, not going to be like very hard thing. You can figure it out. We'll write down like this. Relative motion, I guess you have written that, right? We write a little note. The motion of an object. The motion of an object the motion of an object depends on the observer who's referring the motion of an object depends on the observer referring to that motion or referring the motion. Due to this, the nature of the motion of a certain moving object. Of a certain object moving of a certain object, nature of the motion of a certain object can be described differently when observed by different reference frames. When observed by different reference frames. Different reference frame. We write in a new line. For an example, let's consider the motion of a person walking in a moving bus. Walking in a moving bus relative to a stationary passenger. Relative to a stationary passenger and when observed by a person on the earth. Person on the earth. Okay. Next point, right? When describing the relative motion, relative motions between frames, slash objects. Describing relative motion with frames of the objects, the following notation is used. The following notation is used. Okay guys, so usually if they haven't given the frames or whatever the observers, you need to take them. For an example here, let's say they haven't given any name, so I can mark here this is the person A, the passenger, and C is the conductor. Likewise, you can give some names, like putting some letters here, but you need to describe what you are referring to, right? So this, I'm gonna put the bus itself, and this is the earth, or person on the earth. Earth means the ground, right? So this is the notation, guys. There's a standard way of representing something like this. So the velocity of A relative to B. There's a special way to represent the velocity of A relative to B, and that you can do like this. Since it is a velocity, you can put V, velocity of A relative to B. You can put that one, a comma, and write the relative reference, B. But there are a couple of ways you can write this. Either you can just put VAB, the comma, or maybe you can put VAB just that, right, without the comma, or maybe you can put V brackets A comma B. Either notation would work. So this describes velocity of A relative to B. Whatever the second letter is going to be the relative reference, right, relative frame. First letter indicates the frame or the object that we are referring to. Correct? Okay. So we write the velocity of A relative to B is like this. You can use either notation, right? මේ මොකක් හරි use කරන්න පුළුවන්. Usually I'm going to use this notation, but you can see in the tutor as well, this a just a comma b, and maybe within brackets as well sometimes. This is not the division mark, by the way, guys. Right? I have just separated the three things. මේ ඕන එකක් use කරන්න පුළුවන් කියලා දාලා තියෙනවා. Well, you can maybe mark here. This is the reference frame. This is the object. So as I told you guys, we're going to be continuing with this notation. That's what usually I'm writing, right? But either you can use the others as well. No issue. What if I just write like this? What is that? Can you tell? This is the velocity of B relative to A. That's the overall idea. If you flip the letters, the frame and the reference frame and the object going to flip. So it's going to be the velocity of B relative to A. Okay, let's write that as the next one. Velocity of B relative to A, this. Great. Now we'll draw the bus and these two people and the spy here, right? Maybe he's looking up to something. Okay. So I have to. So today, guys, we are just learning about how we can name these and write the notations. That's all, right? Next day, we're gonna be playing much. This guy is from the FBI and having a binocular, maybe looking at a suspect. All right, so we'll start with this. So what you can say if I write like this? What's the notation that we have prepared? Velocity of the bus relative to Earth, right? Okay, this is the Earth. You need to write it. What's the name? Velocity of the bus relative to Earth. Okay. What's that velocity, guys, by the way? V bus relative to Earth is, yeah, 20 meters per second. To which direction? Seen from the Earth, this FBI guy sees the bus is moving forward to the right side. So we know that we are dealing with vectors here. Velocities are vectors, so make sure you just write it like that along with the direction. What's this? Velocity of A, the passenger, relative to the bus. Okay. Just write there the velocity of A, not the passenger, but it's okay, right? You can write it. Velocity of the A relative to the bus. And don't worry, guys, we are not always writing like these stuff. Still, we are getting the practice, that's why we are writing the names. What's the value here, guys? Velocity of A relative to the bus. Relative to this bus. Is this person moving? No, right? Yeah. Okay, yeah. So it's like maybe the driver, right? Let's say the driver is the bus. Of course, the bus can't observe the others unless it's like a, okay, whatever, right? So let's say the driver is the bus. So it's just driving and looking at the back. So this guy sees the driver, maybe sees the A is sitting, maybe at rest, right? Relative to the bus, the A is at rest. So this has to be 0 meters per second. Maybe you can mark a direction too. To this side, it is 0. By the way, this is called a zero vector. Okay. It's called a null vector yeah, the vector part, please make sure you just go through that. I have already uploaded it, right? And there's a special announcement I had to make, but I thought maybe I could just say it at the very end. But since you are conscious now, and at the very last mode, you're gonna like pack up the stuff and in a mind to run, I'll just say it now. So once we finish up this part, the relative motion, maybe the next week, we can finish this part. And in the following week, we're gonna have the unit tests, right? So that's from all the parts that we have discussed up to now. So since you're gonna have like still you have the time to watch the previous classes, I'm recommending you again to go through the vectors part. If you can't understand anything, just let me know. I know that watching 8 hours is not feasible within one day. That's totally fine. You can have the can use the entire vacation. Afterward, you're gonna start the schools. So you're gonna have a whole lot of workload coming on from the schools and from the classes too. So make sure you are okay with this stuff, right? So not this the coming week Saturday. Afterward, I think in that case your school is also being started. So yeah, please make sure you are getting ready for that unit test too. Uh, even though it's said to be unit test, it's asking from the entire first unit and also a little part from the second unit, which means all the way up to the relative motion. So just use this week to go through the vectors part. And if you can't understand that one, just let me know so I can maybe do some sort of arrangement. Maybe I can arrange a class after schools too to cover the beginning part, right? For any of you guys, if you can't get that concepts via YouTube, right? And again, I'm not getting paid because I don't have that 1,000 subscribers, right? So you can just watch it anytime you like, right? So make sure you just go through that part. All the classes up to now, I mean, not for the recent week, but before that, I have uploaded all the classes. So make sure you go through them. Right? ඒ videos ටික පොඩ්ඩක් බලන්න try එකක් දෙන්න පුළුවන්ද කියලා. Scores පටන් ගත්තාම තමයි catch up class එක දාන්න ඉන්නේ. In case if you need. If you're not fluent enough with the beginning parts like this measuring instruments and the vectors, we can arrange that catch up class. If you're okay with that, I think no point of having that, right? If you are okay again, right? Just let me know. That's why I'm just recommending just watch that class. I think I have given you the tutor. Tutor වෙන tutor එකක් දුන්නා නේ. Vectors tutor එක මම දෙන්නම්. Make sure you go through that part and I think this is the tutor. And that's about the unit test. We'll continue with this lesson. Right? This is called the null vector because it has a zero magnitude but can consider a certain direction called a null vector. Okay. Yeah. Okay. So we'll consider about this. Like this. What's this one? I get the notation. It's the velocity of the conductor. Velocity of C relative to A. What's that velocity? Yeah, relative to the A. He sees that the conductor is moving forward. Like that. Like just 2 meters per second and forward. Okay. 2 more things we're gonna write and we're gonna wind up for today. And velocity of C What's this? Yeah, you can write. What's that? Velocity of C relative to E, right? Yeah. How you write that? V C E million. Okay, that's the issue, right? So you're gonna see the bus is moving forward with 20, and within the bus we're gonna see that this guy is moving forward with 2. Bus එකේ එළියෙන් බැලුවම කවුද වෙන්නේ? ගාලා බස් එක යනවා පේනවා. And the conductor inside is walking with 2 meters per second. So this guy will see, adding up the two velocities, it's going to be to this side 22 meters per second. 2 meters per second plus to the same direction 20 meters per second, so 22 meters per second. And here it's pretty easy because the two movements are to the same direction. But if it's to the opposite direction, one, or maybe one is to going up and the other one is to this side, maybe the bus is moving and maybe the conductor here is just climbing out the the ladder behind, right? Maybe he forgot. මෙයා මේ මොකද load කරගෙන ඉන්නකොට මේ බස් එක ගිහිල්ලා, so he's just climbing up like this. මෙහෙම ගියොත් එහෙම then it's going to be somewhat hard to explain, right? So in this case, we can just explain it very easily. So if it is a scenario like this, we're gonna learn a specific way to calculate the relative velocity. If it is not to the same direction or maybe inclined like that, right? Okay, great. So we write 2 more, and that's velocity of A. This is what? Yep, what's that? Velocity of A relative to E, we write faster. Velocity of A relative to E is what? A relative to E, $20, right? Bus velocity, right? So it is 20 meters per second. Mark the direction to this side. And finally this one. අන්තිමට ලියන්න දන්නේ. What's the last one? Velocity of Earth relative to A. Write with words. Velocity of Earth relative to A. Okay then. 20 meters per second. Which direction? Relative to A means we should go to the A's perspective and look through the shutters. You can see that the guy with the goggles just passing by to the backwards, right? This guy is passing back. So that is, which is equals to this side, 20 meters per second. And last, you can write a star, putting a star mark. What's the difference here, guys, with this and this? You can see here the observer and the object, or the frame of reference and the object has been flipped. So it just changed in the direction of the vector but keeping the same magnitude. Right? මේ දෙන්න මාරු වුණාම direction vector direction එක change වෙනවා but have the same magnitude. Right? So we write that one putting a star mark and that's all. Right? When the observer and the object interchanged, only the direction of the velocity flips, keeping the same magnitude. Okay, guys. So that's it for the relative motion that we are going to learn today. But I told you, like when they are not moving to the same direction, or maybe this guy is also moving. Earth station is a we can say this, and this is also stationary, so no issue. With relative to the A, we can express the C. With relative to the E, you can express the motions of C, A, or the bus. But what if like the FBI guy here is also moving like to this side with a certain velocity? එයත් අර goggles දෙක දුවන ගමන් බලන්නේ. If he also has a certain velocity, maybe 10 meters per second, then can you just explain like this? No, right? So we're gonna learn if there are many motions between the frames, how we can express the motion relative to another moving frame as well, right? Which we can do on the next day. And the homework is going to be going through the previous classes and completing up all the questions that are there for the for the projectile, right? They are going to be, guys, how much of MCQs? I think last day I asked you to do a couple of them. So you can literally try all the questions up to 104. The MCQs 104, starting from the page, starting from the questions on page 20, 63. 63 to 107 means around 40 MCQs are there, and you should have at least complete up many of them as I asked you to do it on previous week. So and the essay questions, I think there were a few questions that you need to try apart from the what I have been asked, right? Now you can do that 30, no, sorry, 50, that whatever the question I can, yeah, 45 now you can do. 43, 44, 45, and 46. If you couldn't do them earlier, now it's time for us to finish. Like still the 42 as well, right? 42 can pull on. It's time for you guys to try them before the next class, right? Relative velocity part we can see on the next day. Right? See you then. Thank you for sharing the class and have a great week.